Hi everybody, welcome to the Evidence Synthesis Ireland webinar series. There is a chat function in the bottom. If you have any problems or if you can't hear me, please let me know. I'm just going to do a brief introduction about ESI and for Chris Noone, who is online here today, just as we're waiting for some other people to join. So Evidence Synthesis Ireland, which includes Cochrane Ireland, is an all-Ireland initiative funded by the Health Research Board and the Research and Development Division of the Public Health Agency. So our aim is to build evidence synthesis knowledge, awareness and capacity on the island of Ireland. And we have a number of key activities, including this monthly webinar, which will be on an evidence synthesis topic. And we have these topics based on your feedback. So I would really ask you, if you have anything that you would like to hear a bit more of, let us know in the feedback forms or email us at esi@nuigalway.ie. And we will have time for questions at the end. So if you have questions, please type them into the Q&A section at the bottom, and then I'll moderate them and I'll ask Chris afterwards. So thank you so much to Dr. Chris Noone, who is our presenter for today. Chris is a lecturer in the School of Psychology here at NUI Galway, where he primarily teaches methodology and statistics. Chris did his PhD in NUI Galway, in which he critically analysed claims regarding the effect of mindfulness meditation on critical thinking skills. He also holds an MSc in Applied Neuroscience from Leiden University, and he has contributed to research on a wide range of topics related to health, wellbeing and cognition, and he collaborates closely with the Health Behaviour Change Research Group and the Medal Research Group at NUI Galway. And he's also chair of the research subcommittee for the National LGBT Federation. And Chris's research interests are on health behaviour, LGBT plus health and cardiovascular health. And today he's going to be delivering an introduction to network meta-analysis, and he will offer an introduction to these steps and how to conduct a study involving network meta-analysis, and he'll use a recently published example. So Chris, hopefully we'll be able to hear you soon and you can share your slides with us. I'll turn on your video.
Okay, thanks very much for the introduction. Let me just share my screen. Okay. Thanks very much. I'm delighted to be here and giving this introduction, beginner's guide to network meta-analysis. So many ways I feel like I'm actually the beginner here because it's still quite a new topic for psychologists. So this network meta-analysis has been in development in medicine and other health sciences for over a decade, for almost 2 decades. But yeah, it's quite a new thing for us in psychology. So I'm going to present some introductory concepts that are useful for anyone who's thinking about using network meta-analysis, and some step-by-step instructions on how doing a network meta-analysis can differ from a typical meta-analysis or a typical systematic review. We've published some of these insights and guidance already. So we have a primer in Health Psychology Review, which is mainly focusing on how you should particularly think about the considerations that go into applying network meta-analysis to any sort of behavioral trial or any set of behavioral trials. Then we have a tutorial published in the European Health Psychologist, which provides data and some step-by-step instructions on how you would actually apply network meta-analysis to that data and the code for running those analyses. So what I'm hoping to get through today is the following. Just a couple of notes on how we make decisions around whether a particular intervention in health is useful or not. then a brief overview of how network meta-analysis works, then some important considerations for applying network meta-analysis to complex interventions, and I think most interventions in health are complex in some way. And then we'll look at the step-by-step introduction to a network meta-analysis, and I'll use the example of a study that we published recently, and we'll end with some useful resources that might make network meta-analysis a bit more accessible. So we need to make decision-making, or we may need to make decisions about health interventions all the time, about whether we decide that something is working, how does its efficacy compare to other interventions, and ideally we should be able to identify what the best intervention option for a given outcome in a specific population is. And typically we have relied on what we would call pairwise meta-analysis, so comparing one condition to another, and taking all the trials that compare these two conditions and synthesizing the information from all those trials. And typically it's some sort of active intervention versus treatment as usual, or some sort of control group. In my field in psychology, that can be kind of problematic because, as you see from the example here, which is a meta-analysis on the treatment of social anxiety disorder, there are lots of different types of psychological intervention, and actually there's also a lot of different types of control groups that are used across all of these different trials of treatments for social anxiety disorder. So to actually combine all of these interventions into something called psychological intervention, even though you've got cognitive behavioral therapy, cognitive therapy, social skills training, and so on, is to actually it actually kind of breaks one of the main assumptions of meta-analysis in the first place, that there is some sort of common effect or common distribution of effects that we're trying to synthesize all this information from. So really you'd expect there to be a different effect of cognitive behavioral therapy versus social skills training versus relaxation. So we lose a lot of information by combining them all together or lumping these all together. And similarly with the control groups, each control group will actually produce a different effect size when you compare it to the psychological intervention. So just combining them all together and lumping is difficult for our interpretation of the results, and really causes a lot of heterogeneity. So this has been our typical approach to looking at synthesizing evidence from trials, but as you can see, it doesn't really totally solve or give us the answers to the questions that we want to know. It can give us a general idea of whether health intervention works, and we can be a bit more focused than the research question was in this example, where they talked about psychological treatments in general. They could have just focused in on a very a more narrow intervention, such as say CBT, the most commonly used one, but they ended up lumping lots of different groups, and this happens a lot when it comes to complex interventions in particular, and we'll talk about that later. It can tell us how efficacy compares to other interventions if we have enough direct comparisons available, if we have enough trials of one intervention versus another intervention that we can do a pairwise meta-analysis between those. But we don't see that much in the literature, so this is kind of a qualified tick. And Then lastly, if we want to know what the best intervention option for a given outcome in a specific population is, we don't get that information from a pairwise meta-analysis. It tells us what works, but it doesn't tell us what works best. So we had a list of different psychological treatments for social anxiety there, but they're all just lumped together. We don't know which is actually the best one. And that's really the important information at the end of the day that any practitioner would want to know, or any policymaker who's deciding where funding should go will need to know, is not do all of these tend to work on average, all of these different types of interventions, but which one of them works best. So using network meta-analysis, we can actually answer all of these questions with quite a lot of detail. So we can answer whether something works and respect differences between control groups. So we can split out all the different interventions and all the different control groups. We can compare all the different interventions to each other and to the different control groups. But we can also get an estimate of what the effect size between interventions that actually haven't been compared to each other yet might be by using indirect comparisons. And I'll explain them in a bit more detail soon. And finally, we do get an idea of which is the best intervention option. And there's lots of different ways of quantifying the ranking of the different intervention options. So here's an example of the same topic, social anxiety disorder, but all the different intervention options have been focused on for this meta-analysis. So not just psychological treatment, but also pharmacological treatment, and exercises in there as well, different types of exercise. So now, rather than getting just this one lumped effect size for psychological treatment in general versus a lumping of different control groups, now we have a better idea of, now we can get effect sizes for all of the comparisons between all of these different intervention options. So typically we get a network that looks like the picture on the left here. So that the size of the circles those circles are called nodes in the network, and the size of that node will correspond to the amount of participants that that contributed data to that particular condition. So you can see that most people would have taken part in the SSRI condition across many different trials, and the placebo condition across many different trials. And the thickness of the line between connecting these two nodes, that's an indicator of the amount of trials that have compared these two conditions to each other. So we can see that this is the thickest line in the network. Therefore, most of the trials focus on the comparison between SSRIs and SNRIs and placebo. So we have lots of other different connections between, we have direct connections like this and this one. We could also find out the indirect effect between, say, the SSRIs and exposure and social skills. They haven't been compared to each other. There's no line connecting them, but they will have both been compared to group CBT, for example. So we'd be able to get an indirect comparison of the so an indirect estimate of the effect size between SSRIs and exposure and social skills. And then we'll get a table that gives us the effect size between every single pair of interventions. Okay, so let's take a quick look at how network meta-analysis works. I'm not going to go into too much detail about this, but I can recommend some further reading at the end. So basically, network meta-analysis is a tool which enables us to synthesize all of this evidence from many different treatment comparisons together, and crucially allows us to integrate both the direct evidence from head-to-head trials and the indirect evidence that so this is where we have between trial comparisons of different interventions. So take, and I've just shown you an example from social anxiety, but the general example is that, you know, where pairwise meta-analysis just focuses on the comparison between A and B, network meta-analysis could look at, you know, the simplest network would be a network of 3 interventions like this one. We could look at the direct comparison between A and B, the direct comparison between A and C, and even if there has been no direct comparison between B and C, we can look at the indirect evidence. And if there has been direct comparisons between B and C, we can integrate, we can pool both the direct estimate and the indirect estimate and get our network estimate. So that's really making use of all the information that's available, all the evidence that's available. So yeah, network meta-analysis was developed from this initial idea of simple indirect comparisons, and the formula that was developed by Bucher et al. Works like this. So the idea is that we get our indirect comparison. In this case, we have a network where, if you imagine a group of people who are hypertensive, and they've been across many different trials, that there have been trials of reducing the amount of salt in the diet, and there have been trials of physical activity to reduce hypertension, and then most of the time they're compared to treatment as usual. And imagine there's been no trials that have actually compared physical activity intervention to salt reduction interventions. We can make an indirect comparison by taking the direct comparison of the physical activity and control group, and subtracting away the estimate of the comparison of salt reduction interventions with the control group. And that will leave us with an indirect comparison, an estimate of the difference between these two types of interventions, the physical activity and the salt reduction. So in general, the equation looks like this. And we also need to get the variance for the estimate, and because the trials are, we're taking between trial comparisons rather than between participant comparisons, and the trials are independent, and that would mean we add the variance of the different estimates together. So that means that indirect evidence will have higher variance than direct evidence. It just means it's going to be less precise. But then when we combine it with direct evidence, we end up getting a more precise estimate than if we just had direct evidence alone. So now we have much more sophisticated models that have generalized this indirect, this simple indirect comparison to whole networks that can have as many different comparisons as you can find. But the key thing is that we're not looking at the absolute comparison between treatment arms across studies. We're looking at the relative. So here it's the effect size of A relative to C and the effect size of B relative to C. that allows us to get the indirect comparison. So we're respecting the fact that the participants in these trials were randomized to interventions within the trials and not across the trials. So we're going to look at some assumptions of network meta-analysis now. And if you're familiar with traditional meta-analysis, pairwise meta-analysis, you'll be familiar with the idea of heterogeneity and homogeneity. And these additional ones, transitivity and consistency, are essentially other ways of looking at the idea of homogeneity. They're nothing completely separate or unique within network meta-analysis. They're just another way of thinking about the same assumption. So homogeneity basically refers to the idea that we want to be sure that we're comparing like with like within a meta-analysis. We want to make sure that all the trials that we're synthesizing evidence from are either, if we're assuming a fixed effects meta-analysis, are either estimating the same effect, or if we think about random effects meta-analysis, that they're estimating effects that come from the same distribution. As we saw in the first example with the pairwise meta-analysis of social anxiety interventions, we can introduce a lot of heterogeneity if we're not very specific about the intervention that we're going to be synthesizing evidence from. But then in the second example with the network meta-analysis of interventions for social anxiety, we were able to split up all these different interventions into their into the specific type of interventions and then compare them to each other. So that would have helped deal with heterogeneity. But one problem is the more that we split, the more that we split up different interventions, we can end up with disconnected networks. So we can have all different types of networks with, but they do need to have common comparators somewhere in the chain. Okay, so we've got B is always connecting everything, everything is flowing through B. It's probably some sort of control condition or treatment as usual here. But then, for example, if there's a trial if there are trials that compare intervention E to intervention F, but not to the original treatment as usual condition B, then that becomes a disconnected network. So we'd have to try and find some trial that that may have compared either F or E to B, or one of the other parts of the network, A, C, or D. So that's, just highlighting the disconnected network there. So there are some methods for dealing with disconnected networks, but they're quite complex. Okay, so if we look at transitivity then, this is the assumption that the mean effects estimated by the different set of studies for each comparison are the same as the effects that would have been estimated if a large multi-arm trial of all the same interventions had randomly allocated all of the same participants across those interventions. So that's one way of thinking about it. There's many different ways of thinking about transitivity, but the idea is that there shouldn't be any differences in the distribution of what are called effect modifiers across the different comparisons. So it shouldn't be the case that there are, say, a bigger number of, in this case, a bigger number of females when you compare C to A than when you intervention C to A than when you compare intervention C to B. Oh, sorry, yeah, C to E versus C to B. So you could think about, there may be some interventions that, or some comparisons that you only see in an older cohort, or that are only delivered in kind of more wealthy or less wealthy settings, things like that. You need to be really aware of what could be potential effect modifiers that are not balanced across the network. And lastly, we have consistency, and consistency is focused on the idea that we need to check whether evidence from indirect estimates agrees with evidence from direct estimates. So it's an important check before any network meta-analysis is undertaken to see whether the evidence from both the direct and indirect comparisons are consistent. So just to sum up, I guess, why is network meta-analysis useful? Well, as you can see, it maximizes all of the available evidence. So we can take in trials of all the different types of interventions for a particular condition. And then we can make use of the fact that that network meta-analysis can pool both direct and indirect evidence, so that we get more precise effect sizes for each comparison between each pair of interventions. We get a ranking of the different interventions in the network, and that's really useful for decision making in terms of, if there's a clear top 1 or 2 or 3 interventions, that those are the ones to invest in, and that's part of the reason why it's become a key component in the development of clinical guidelines and reimbursement recommendations by various national health technology assessment agencies and the World Health Organization. And what I find really interesting is that it can reveal the most effective components of complex interventions. So we're going to have a look about different considerations in relation to complex interventions next. And interesting as well, I think that network meta-analysis seems to pop up a lot in these different hierarchies of evidence that you see now and then. I guess because it's taking in so much evidence, using it in a very efficient and clear way, and giving very practical results. Okay, so let's look at some important considerations for applying network meta-analysis to complex interventions. So complex interventions, I think a lot of people consider, I guess, complex interventions to mainly be ones that have a behavioral component or explicit behavioral component, but many interventions have lots of implicit behavioral and organizational components as well. So I think a lot of interventions, if not most, in health research are complex. When you think about the number of interactions between components in the interventions, the number and difficulty of behaviors required by those delivering or receiving the intervention. Even a biomedical intervention can be quite complex in terms of the instructions that have to be given on how to use a particular medication, and the expectations placed upon the participant in terms of following those instructions with fidelity. Yes, the idea is that with these complex interventions, there's a lot of different components, and we may not know what's the actual component that's contributing most to the effect of the intervention. And that can be something that we're interested in. Sometimes we just want to know, does the intervention work or not? But if you want to optimize an intervention, you want to know which parts of it work really well, which parts of it don't seem to be doing anything, or are there certain parts that interact with each other in a way that produces a better result, or interact with each other, in a way that is kind of competitive, that they actually cancel each other out in some way. There have been some methods in network meta-analysis developed for addressing these issues, and I'm going to show you some of those. Just some things to think about when looking at the application of network meta-analysis to complex interventions is how are they developed, and can you get good information on how the interventions in the trials that you're focusing on were developed, especially if they're behavioral interventions. There may be important differences as to why particular behaviors are being targeted, or why a particular set of ways of targeting those behaviors are being used, and that might affect actually the transitivity issue, because if it's the case that certain kind of subgroups within your target population are targeted for different interventions, or different types of behavioral intervention, that's an example of an effect modifier that's differentially distributed across your network then. So that's kind of breaking that transitivity assumption. It's also important to consider what the content of control groups is. Often we just think about control groups as being this kind of inert thing that doesn't have any sort of influence on its own, but actually most control groups can have quite a lot of active ingredients, and so we should be able to identify what those are, so that we can group the different group similar control groups together, the ones which actually may have a more similar effect. And risk of bias can be trickier to control certain sources of bias in complex interventions, and bias can really affect the estimates in network meta-analysis in ways that are hard to pin down, because there's some methodological research that suggests that bias can propagate through a network and affect other parts of a network than where the bias is actually originated from. So something to be aware of. So the ideal conditions for a network meta-analysis would be if we always had availability of both direct and indirect evidence. Sometimes we only have indirect comparisons between interventions. If we always had valid and reliable measurement, and that would be helped by the use of standard outcome sets. And if we had transparent reporting of intervention methodology and results, and the compulsory sharing of individual level data. So we can integrate individual participant data into network meta-analysis, and it actually will improve the performance. Okay, this is just an interesting paper I wanted to highlight that shows the importance of really looking at the content of control groups, as I mentioned there, because something that's referred to as usual care doesn't mean that it's the same as another paper that has a usual care condition, and yet we'll end up pooling them in many evidence syntheses. So it's important to really think about how we can identify what's going on in control conditions, because we can actually use network meta-analysis then to model how different control conditions lead to different estimates of the effects of interventions. So we can use different, within health psychology, We have many different tools for describing the behavior change techniques, the modes of delivery, the settings in which interventions take place, the theoretical constructs that are targeted within interventions, and the mechanisms of action that are hypothesized within interventions. And these are all different pieces of information that you could use to define your network. You can use these to code conditions from trials, so that you can make sure that you're grouping like with like. And if you do that coding in a very fine-grained way, and you figure out specific components within complex interventions, you can do some very interesting stuff based on the work of Deborah Caldwell and Nikki Welton, and use what they refer to as components-based network meta-analysis. This basically allows you to deal with a high degree of heterogeneity, which is introduced when we try and bring evidence from complex interventions together. And it allows us to look at the interaction between different components of complex interventions, which, as I said, can be very interesting. So we can code the different components within, and the different combinations of components within interventions, and then use those combinations of components as nodes within a network. So I'll show you some examples of that being done in a moment. But first, it's important to really emphasize that we need to think broadly about the composition of components within a complex intervention. So there's a good paper there on think about how do we break an intervention down into its, I suppose, active ingredients or its specific components. And there are different ways of thinking about how we might do it. So we might think about that idea of an active ingredient, or the essential techniques, or the most irreducible part of an intervention. Two broad ways of thinking about it, about how to specify the nodes in a components-based network meta-analysis, are to think about the clinically meaningful unit or component dismantling. So clinical meaningful unit would be that there's something that different therapies or different therapeutic approaches or something like that, would something clinically meaningful about how we break down things, or we can have a bit more of a just component dismantling looks a bit more at other issues as well, other things that you can other ways of describing components within complex interventions. And then Welton and colleagues have shown that there are a few different ways of looking at the relationships between intervention components, and you can test each of these out on your data and see which one fits best. So it could be that the additive model fits best, which assumes that the effects kind of sum up together. Could be an interaction effect where pairs of components are assumed to have a larger or a smaller effect when they're found together than when they're found alone. Or you could look at the full interaction, which looks at all the different particular possible combinations. So what's interesting is people don't often clearly describe how they specified the nodes in their network meta-analyses. Only 8% of non-pharmacological NMAs have done that. In general, you can either use a previously published classification or expert consensus to agree the nodes that you're going to use. Ideally, you do that a priori. It's clear that that's not happening a lot though from reading NMAs. So here's just a very quick example of a component network meta-analysis looking at the components of psychological interventions for just for pre-surgery. And this was useful because it identified that, you know, they broke down each intervention into a combination of these 6 aspects. So procedural information, these 6 components: sensory information, behavioral instruction, cognitive intervention, relaxation, emotion-focused techniques. And they were able to work out, based on the results of the component network meta-analysis, that all of these were effective components except for emotion-focused techniques. So that's a very useful and applicable finding. There's a couple of other examples here which you can look at if you get the slides afterwards, but I think I'll keep moving on to the next part of the presentation. We're going to look at step by step what do we do when we're conducting a network meta-analysis. I'm going to use a study that we conducted here in NUI Galway, focused on trying to compare the differences between physical activity interventions and antihypertensive pharmacological interventions in trying to reduce blood pressure in people with hypertension. So we published the protocol, the systematic reviews, and the results paper in the European Journal of Preventive Cardiology. So I'm going to go through the main steps that are similar to any sort of systematic review or meta-analysis, but just point out when there's slight differences because you're doing a network meta-analysis. The first thing to point out is that there is a Prisma extension for a network meta-analysis, and it's essential for reporting your results when you get that far, but I find it a really useful tool right at the start for planning your systematic review. I suppose one thing that's different about how you define your search in a systematic review is that your PICO is going to be a lot broader. So your population should still be quite focused, but obviously there'll be more than one intervention. There'll be more than one comparator. It's possible to look at different outcomes. There are multivariate versions of network meta-analysis. But yeah, the main thing is that your intervention, your comparator will be part of your PICO will be much broader. You should, at this point, you should also be already identifying potential effect modifiers. And obviously you would register your plan in something like POSPRO or by publishing a study protocol. So in our study, we were focused on people with poorly controlled blood pressure or diagnosis of hypertension, but we had a really broad intervention and comparator criteria. We were looking for any sort of intervention that was intended to reduce blood pressure in people with hypertension using either some sort of physical activity or any first-line antihypertensive therapy. And we were open to any type of comparator that could come through, that could have been compared to those interventions. And we anticipated that, you know, we would see probably pharmacological placebos, treatment as usual, maybe some sort of active behavioral control groups. We were looking at blood pressure, systolic and diastolic, at 8 weeks as the outcome. So when you're conducting a search for a network meta-analysis, it can be quite challenging to deal with the amount of citations that or the amount of abstracts that can come through such a broad search. So some people do take the strategy of just going to previous systematic reviews, sometimes just taking the trials from a combination of previous systematic reviews. This can be difficult if the inclusion criteria varies a lot across those systematic reviews. So safest option is to go through a primary search yourself, although that might not be feasible if you have a huge amount of trials to deal with. So you can be careful about the restrictions that you include in the search strategy to try and make the amount of abstracts you have to deal with a bit more feasible. So we end up with a huge amount of abstracts to deal with. We searched three databases and did the usual kind of screening. I ended up with something like 30,000. I think I have it in another couple of slides, 30,000 abstracts to start out with. So one thing that's quite different about when you select studies within the screening process is that you might end up including some interventions which are not central to your research question, but are compared to your interventions that you are interested in, because that can provide more useful evidence to the network. So yeah, this is our screening process. Started out with around 33,000 references imported, huge amount. We eventually got there and got down to 93 studies, 12 focusing on exercise or physical activity, and 81 on medication. So ideally, you will have made your decisions about splitting and lumping and specifying your nodes in advance. But I think practically a lot of this stuff happens after the data has come in. And sometimes there is a lack of data in some places, and you end up having to lump, even if you had an a priori idea of how you wanted to split things out in your network. So you should create a network diagram then and evaluate the geometry of that. There's some good recommendations for how to do that from Noone and colleagues. So this was our network diagram. We had mostly the first line in antihypertensives and then some exercise trials. But you can see we had a lot of second line combinations as well, just because they were often compared to the first line antihypertensives. So when you analyze your data, first you have to check consistency. That's not something that you would normally do in a pairwise meta-analysis. You should present pairwise meta-analysis for each comparison. So you can see that here's an example of that. And then present your network meta-analysis in both the forest plot and then this kind of table of estimates. So we get which shows the effect size between every pair of estimates. So the forest plot, you might just show the comparison between each intervention and one specific comparator that you're interested in, like placebo here, or here we're showing each intervention compared to the control condition. We show that there wasn't much difference between all the different types, but that the first line antihypertensives were more effective than exercise. When we looked at the focal comparisons, because we were interested in not necessarily how these all compared to the control condition, but actually how each of the first line antihypertensives compared to exercise and physical activity. And we found that there was no difference between physical activity and exercise when you compared it to calcium channel blockers, thiazide diuretics, and ACE inhibitors, but there was a difference. Here, a very small one. Mostly this, you can see that the confidence intervals are very wide though, so probably mostly due to a lack of power. Similar findings for diastolic blood pressure. And there's our rankograms, which did show that the first line antihypertensives were the most likely to be beneficial. So just finish up now by showing some useful resources. I won't go through this slide in too much detail, but you can look at our paper in Health Psychology Review to see the different types of software that are available for doing network meta-analysis and their different features. There's some interesting and quite accessible pieces of software online for carrying out network meta-analysis. And you can get the links to all of these on the Cochrane website related to network meta-analysis that I think Nikita is going to share around. I also recommend the book by Diaz et al., Network Meta-Analysis for Decision Making. So these are the three online. So you can do a full network meta-analysis on this online in a point-and-click fashion. But to be honest, I wouldn't recommend doing a network meta-analysis without the input of a statistician. This is a way of applying the grade technique to the evidence from network meta-analysis. And if you're working in pharmacological research, then this is a very useful tool. So I hope that was useful. We looked at, why network meta-analysis is useful for decision making, quickly how it works, a very brief introduction to that, and some aspects of why it's so useful for complex interventions, and then how you would apply it. So just acknowledge collaborators and the funders from the research that I presented to you, and then if you have any questions, you can either ask through the Zoom or feel free to email me or get me on Twitter.
That's great, Chris. Thank you so much. I'm just going to ask a couple of questions and give a little bit more information. So while I'm waiting for some questions to come in. So if you do have any questions, please pop them into the Q&A box there. So that was such an interesting talk. Like the power and the utility of network meta-analysis really struck me, and just the impact of that data visualization. It's just so clear. You did mention the Cochrane website online, so I wanted to highlight there's a Cochrane Training Learning Live webinar series on network meta-analysis that's available on training.cochrane.org, and I'll actually put the link to this on the website, on our website, evidencesynthesireireland.ie, along with today's recording that we'll put up today, this evening. And there is also a Cochrane interactive learning module on network meta-analysis, but that's free for Cochrane authors only, but there is a fee for non-Cochrane authors. And Chris, you're also going to be teaching on network meta-analysis with UCD Public Health. That's on the 19th of March, isn't it?
Yeah, I think so, yeah. I think they have a 3-day course on the 18th, 19th and 20th.
Yeah, and so you can sign up to just one day or another, and we'll be sharing details of that in our newsletter. So if you're not already signed up to our newsletter, please do go to evidencesynthesireireland.ie and you can sign up there, and you'll hear more. So Chris, so what do you see as the key next steps for NMA in terms of methodological developments that need to be explored?
I think it's going to be, I'd like to see more development of this component based network meta-analysis in our line of work. We look at interventions that might have 3 or 4 different hypothesized methods of action, and there's been a lot of there's a lot of those behavioral trials out there, and they can be coded, and that we can identify the components that are most useful then to optimize further future development of behavioral interventions. So the specific methodological development there that's being worked on, as far as I know, in UCL is attempts to use AI to automatically kind of read papers and recognize where different types of intervention components are in specific interventions, and automatically scrape the data that we would usually have to painstakingly read through a paper to to extract. So yeah, more automation of these processes, and there's collaborations between the Centre for Behaviour Change in UCL and IBM, focused at eventually, you know, kind of blue sky thinking, eventually having a system where practitioners can basically, you know, look up the relative efficacy of one intervention versus another, or the ranking of different interventions, and that the evidence feeding into that system would be constantly updated from the literature as new studies get published. So
you actually answered my
far down the line, but yeah.
Yeah, you answered my next question, which was how technology can help. And then, so this is, you know, quite skilled, and you mentioned that you really need a statistician on board as well. So, like, how do we incorporate NMA teaching and training into student education, and is it being done, and should it be done, and what level should we be doing this?
I mean, I think it should be introduced. I think evidence synthesis in general is probably something that's not taught to students early enough, and you know, these online tools that I showed very briefly at the end are quite accessible and easy to use. So you wouldn't, like I was saying, I was kind of cautioning against using them for research and saying that you should bring in a statistician for those, but they're brilliant as teaching tools.
Okay.
And they come with, you know, already prepared data sets that you can use to demo the software. So yeah, so I think there's no reason why we can't. I don't think it sounds like a basic approach to it is could be done within masters, any sort of health research masters courses, and those tools in particular are useful for doing it in an interactive way.
Great. Well, I'm conscious of time, so I just want to thank you again, Chris, for your time and effort in that really informative presentation. And I hope everyone attended found it useful as well. As I said, we will put it online. We have monthly webinars, which will be on a variety of evidence synthesis topics. And next one is in March on the 27th by Ruth Garside on its qualitative evidence synthesis. You will receive a feedback form as well, so please do fill that out, because we listen to your requests for future topics. And you can follow us on Twitter at evidsynRL. Thanks everyone for listening, and thanks again to Chris, and we'll talk to you soon.
Thanks everyone.
Bye.